Question 6 here. So I'll probably break these up into 2 videos. I'm going to do part A first. That one should go a little bit quicker. We have someone's on a boardwalk, kids on a boardwalk, calm waves. So, nice calm waves. The kid has a boat attached to a string, and they're pulling the string in at a rate of 2 feet per second. Here's our boat. This string is going in at a rate of 2 feet per second. And then 10 feet above the water, 20 feet from the dock is that when we are trying to answer question A. So how fast is the boat returning to the shore? At the moment, it is 20 feet from the base of the dock. So this is getting pulled in. The rate at which it's moving towards the shore would be the rate of change of this thing. So I'm going to draw a little right triangle. I'm going to label an X, a Y, and a Z. We don't need that theta yet, so I'm going to leave it there. We know dz over dt is equal to -2. And we know that dy over dt is equal to 0. And we want to find dx, we want to find dx over dt equals what? So I'm going to start with some pythag. X squared plus y squared equals z squared. I'm going to derive with respect to time, d over dt. I'm going to get 2x times dx dt plus 2y times dy over dt is equal to 2z times dz over dt. From there, I'm going to divide everything by 2. That gives me x times dx over dt plus y times dy over dt equals z times dz over dt. Now, what do we know? Well, we know dy dt is 0, so I'm going to get a 0. I know dz dt is -2. So I'm going to make equals -2. So I'm just going to write y times there because we're going to get 0 out of that. Doesn't matter what the y value, what the height is. It's 10. I guess, well, it's fine. We'll leave it like that. And then I know my my x value is 20. That is 20 at the time that we're given it. That's right there. Times dx over dt. I'm going to put that in like that because that's what I'm looking for. And we do not yet know, and actually I wrote this a little bit. Let me erase this. I'm going to write times -2. So I don't have the z yet. Well, how do we find the z? Well, we plug the values we have into that Pythagorean theorem. And I can do that now because I've already I've done the derivative line. If you do that, you get z equals the square root of 10 squared plus 20 squared. And if we round that to 3 decimals, we get, or I guess 2 decimals, we get 22.36. Now, remember, when we're doing this, we don't want to round until the end, so I have it rounded there, but I'm going to store the value in my calculator and make sure that I don't round until the end. So all I got to do is find my dx dt. This term goes away. That's why I didn't care about plugging in the y equals 10. So I'm just going to divide both sides by 20 to get that dx over dt is equal to 22.36, which I could consider that to be just the square root of 500, if I wanted to not write it as a decimal, times -2 all over 20. And when I simplify that out, we get -2.3, or sorry, not 2.3, 2.236 feet per second. Now, if we look carefully at what it is asking here, it says how fast is the boat returning to the shore at the moment, blah, 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 blah. Returning to the shore is how fast is it coming in. So we do get a negative here when we do our math because that negative carries in. But with how the question is asked in this scenario, I would personally give it as a positive number because that's how fast it is returning to the shore. Okay, so that is this question, and I'll, if you want to see how to do part B, there'll be another video.